Uh, I am using uh, Java as a language for this session, but the topic and the discussions are applicable to all the languages. When I say all the languages, I primarily talking about object-oriented languages. So this session is primarily for object-oriented programming languages and may not be applicable for functional languages. So, before we start talking about what is clean code, any ideas what are why do we need clean code? If you see the software development, we all know that development is just 25% of the part of software development lifecycle, uh, whereas 75% is part of the maintenance. And that is a very important truth. And because of that, it may be fine that you are able to develop the code, but we need to make sure that the code is in a state where it can be maintained further. When I said maintained further, the people who were part of the development team may not be part of the maintenance team. And if the code is not maintainable, readable, then you may be spending much more time and money uh, in maintaining it than you did in as part of the development. So not only as part of the maintenance, but also during the development as well, we want to make sure that we should be able to work on anybody's code. uh, you might have seen certain situations where people don't want to venture into a code base where um, where they are not very confident, and and then in case they want to make any changes, they just make that particular change and don't touch the whether the code is in a good state or not. And that is uh, because the quality of the code is not good enough so that you are confident enough in making your change. And those are the things which we are going to discuss as part of this session. So as part of the definitions of the clean code, multiple people from the software industry have different perception. Uh, so, for example, Strostrup, Michael Feathers, Grady Booch, Von Cunningham. So all these people have given their own definition. But when I look at those definition, most of those definition are very subjective and may have different interpretation depending on the people. But as I look at the definition provided by the Kent Beck, that is much more objective and makes sense. So when I say that Kent Beck definition is much more objective, this is my personal opinion, and I'm not saying that the definition provided by the other people are not good, but I'm just trying to make sure that the definition of the Canback is much more objective, and you can see like how to use that in making your code cleaner. So we start with the Kant's four rules for the simple design. And even though they are very simple rules, uh, you will find out during the session that all those simple rules leads to uh, very important understanding about the code base and design principles, because that only when you have the understanding of the design principles, then only you will be able to apply, you will be able to create simpler code. or simpler design. So, so let's see what are those four rules. So, first simple design rule is run all the tests, and it it may be looking very simple as I said before, but we will see in the next slide that how it leads to a better design. So other other three rules are can be grouped in terms of the refactoring. So it should not contain any duplication. Your design should express design ideas that are as part of the system. And third one is minimizes the a number of entities such as classes, methods, functions, and the like. So let's start with the simple design rule runs all the tests. When we talk about uh, as part of your continuous delivery and continuous development, you are running the test cases. That means like as soon as you're done from the coding perspective, and you want to move the code into the uh, source repository, you want to make sure that uh, the local build runs on your local machine, and as part of that local build, you run all the test cases. In case there is any problem in any test case because of your changes, you fix that. And during that, you also want to make sure that your code coverage or test coverage uh, is in a higher percentage. So mostly people talk about 75% of the test coverage, and uh, so making sure 75% test coverage or 85% test coverage, and then only you basically move the code into the source repository. So while you're running the test cases all the time, it means that in order to write the test, the code should be testable. Uh, when I say code should be testable, it means that there are a lot of factors because of which there may be difficulties while writing the test cases. For example, high coupling, uh, low cohesion, and it is not following many design principles, and high dependencies. So because of all that, it may be very difficult to write the test cases. So when you write the test cases, you want to make sure that those problems are resolved so that you can write the quality test cases. You are looking at testable code, then you want to make sure that the the classes are small, methods are small, they are using the single responsibility principle, which we'll be talking about in the coming slides. And that way your code base look much more cleaner. So with by just implementing this one, we are trying to cover a lot of things. These are the other three rules, and they are coming under the group of refactoring. And these rules are no duplication, expresses the intent of the programmer, and third one is minimizes the number of classes and methods. So only when you have the tests, uh, you can do the refactoring. When I say that, it means by having the tests around, you have the safety net with you. So in case anything breaks, then your test will tell you that something got broke uh, in this line of code, and you can fix it. If you don't have the safety net, then refactoring doesn't work. you may be looking all around why it has broken, and it may also happen that you have a fragile design where one you make changes here, but the impact of the change may be reflecting somewhere else in a negative way. So refactoring is good as long as you have the safety net around it in form of unit tests, or when I say tests, then basically it is the combination of all the tests, unit integration and the functional tests. So whenever you write few lines, you need to reflect on yourself whether you upgraded the code base or you degraded the code base. And then in case you feel that the code base is not looking good, then you want to use refactoring um, to clean it up and then run the test cases around it. So refactoring can only happen when you have the understanding of the good software design. So these are certain principles which I have written or mentioned over here: increase cohesion, decrease coupling, separation of the concerns, modularize system concerns, shrink our functions and classes, that means small functions and classes, choose better names. So it may happen that you may be writing very generic names like my object X and Y, but when a new person look at it, he may not be able to understand what exactly is trying to do. The code should be able to convey what exactly it is doing. So we will be talking about that as well in the coming slides. So so that's where we apply uh, all these three rules. So let's talk about the first rule of the refactoring: no duplication. So it you can call it as a dry principle as well. Do not repeat yourself. Uh, so so whenever you think about duplication, duplication may be in form of exactly like same lines of code at different places, or it can be similar logic as well, uh, which you can refactor and maintain in a better way. So why what is the problem with the duplication? So any ideas, guys? What is the problem with the duplication? So one answer I get is because it helps to prevent bugs. Is there anything else? So when you have the same lines of code at different places, it just means that you need to maintain at a different places. So whenever there is a change at one place, you need to make sure that the same change is implemented at other place as well, because the logic is same. So any bug means making changes at multiple places. That's why uh, we try to create an abstraction, inform the class, inform the file. So it is not just limited in a class. It can be anywhere. It can be in a for example JSP file as well, where the same kind of view is applicable at multiple places. So you don't want to repeat the same thing again and again, which because it creates the issues. That's why we don't need duplications. Let me move on. The second thing is expresses the intent of the programmer. So very easy to write code which we can understand. So like whenever we write code ourselves, we are in a zone where we really understand what we are trying to do. But think from a perspective of a newcomer who has come as part of the uh, maintenance, and he's trying to fix a bug. So if the code is not clean, it's not able to convey what you're trying to do over there. It may be very difficult for him to understand. So long-term maintenance is the major cost of project, as I mentioned, and code should take minimal time for anyone to understand. So how we can do that? So there are multiple ways to do that. So by choosing good names, so names should be able to tell the responsibility of the method or a field. So not only method but also the field names are very important. Small classes with functions easy to write, modify, and understand. Well written unit tests. So with the unit, if you have written good unit test cases, then you should be with those unit test cases itself, uh, you should be able to get the documentation uh, of the code base. And you can use the design patterns as well. When I talk about the design patterns, then they give a language which everybody understands. So for example, if I talk about that I'm using a command pattern over here, then everybody understand what exactly you mean. So if you use certain uh, patterns, and again, not for the heck of using patterns, but where it is applicable, then also it is very easy to understand. Uh, and lastly, it is important to spend some time to clean your code. The third one is minimizes the number of the classes and the methods. So you might have seen many times that we have a dogmatism many times uh, in our projects, that for each class we should create an interface. Though there are good reasons why we should create the interfaces, but uh, what I've seen is that those interfaces mostly are not used, and mostly they are used just as a one single class. So if in one single class is there, one implementation is there, uh, then what is the need of creating an interface? It may be useful when you need multiple implementation because of many reasons. The reasons can be because of the testability. It can be, the reasons can be like you want to have the different implementation for the same kind of logic. So because of those reasons, when they really arrive, then you can take a decision and do the refactoring on the code base and create an interface. But at that moment itself, when you are writing your first class, I have seen that most of the times you don't need all those interfaces which are created just for the heck of it. And with those interfaces you create a lot of number of classes. So other thing is that many times it happens that fields and behavior must always be separate into data classes and behavior classes. So again, that is also dogmatisms. Try to see whether you can have the abstraction of the data and behavior together. With only data, those you create anemic data models, uh, and if you have the behavior as well as part of it, that is much better. So you need to really see if, I mean, whatever I'm talking about is more about pragmatism, things which make sense. And if you need it, if you don't need it, then why to do that? So the whole point is to have a entire system small. So let's talk about the foundation of the object oriented design. So with this, I will be basically showing you uh, some certain code based problems. So this is problem number one. Any ideas what is the problem here? Just a moment. So the problem over here is that you, we may be breaking the idea of that encapsulation over here. So as you see that there is a list called bars, and we are creating an array list. And when I look for get bars, then I just uh, return the bars. So basically, you give the entire list, and with that, the person who is getting this list, he can change anything in it, uh, which is basically violating the principle of this encapsulation. List is a mutable object over here, and it can be changed when you get it as a client. So let's see what we can do with that. So what we can do is, let's create uh, read only list and return it to the caller. So let's try to do that. So this is what we can do. We can return the unmodifiable list over here. So with that, and we are not breaking any encapsulation. So let me get back to the presentation. So encapsulation is all about hiding implementation details from the outside world. There can be electric wiring which you want to hide with a switch, uh, and you don't want to expose the internal details. So I don't need to explain what encapsulation is all about, but this is an important idea, that you hide the internal details and don't expose when you return it through some certain methods or functions. So let's talk about the problem two. So let me go here, uh, customer service. So this is the code base I have right now, and I have multiple methods in this service. One is calculate order discount. Another one, this customer service has custom calculate order discount, gather order errors, is customer valid, submit order, register, and forward password. The If you see this code base, then you find out that there are this class is trying to do multiple things. And before we conclude that it's trying to do multiple things, uh, the name is also vague. If you see customer service, it means like a kind of dump yard where you can put any kind of methods which are related to with the customer, and that's what's happening over here. So when we talk about the name, it should exactly say what this particular entity is trying to do, which is it is not doing right now. So if you look at the multiple functions or the methods over here, you find out that it is there are two abstractions over here: calculate order discount, gather order errors, is customer valid, and submit order. And another one is register and forward password. So this is more related to the security and or authentication, authorization, and this is more related to the customer service. So Basically, we can refactor it, and with the refactoring, uh, basically you can create multiple classes with this. So let's try to do that. So let's name it as a customer order service, and you can put these methods over here. uh, there is some problem with this line. Order submission service is not there, so let me grab that. So this is one, and let me refactor the other one as well. So instead of creating new class, let me change the name of this class itself. So first, sorry, customer authentication service. So with that, we have created another abstraction. Fine. So let's try to see what it is violating. So single responsibility principle. A class should have one and only one reason to change. Uh, so this is single responsibility principle. So the offshoot of um, s- single responsibility principle, a method should have one purpose, reason to change. When you have uh, one single purpose for the change, the class becomes easy to write and read, which means you are less likely to write bugs. Uh, Write out the steps of a method using plain English method names, uh, because you are focused towards having the more objectivity in terms of the method names. So let's focus on this method, and try to see how we can refactor it further. So whenever I see a method something like this, I mean it becomes difficult for me, I mean, to really understand what is happening. Other thing is you find out is that there are uh, multiple comments which are there in this method. So whenever you see the comment, you find out that maybe uh, it's the method is not saying what it is trying to do, and then you get a tendency to basically refactor it. uh, so let's try to do that over here as well. So the first thing is make the comment is make sure that the order has products. So with that, you can you can basically refactor it in a new method and have the similar kind of name, extract method, and is order has products. Fine. And Second thing is, in case if order doesn't have the products, it shows an exception. And second thing is calculate tax. If order has products, then basically it's trying to calculate the taxation. So you can say calculate tax. And third one is calculates shipping. And again, you can do that. You can refactor this method over here. Calculate shipping. So with that, you can remove all these comments, and it looks much more cleaner. You can also, you don't need to basically remove this and create another method because it is already a smaller one. So if you see that this it is looking like a plain English, and with that you can see what exactly is happening over here versus where we were earlier. So so my tendency is that whenever I see a method and it is more than, for example, 20 or 30 lines, I try to see like what is the abstraction it is trying to convey. Maybe it is trying to convey multiple things in a method, and you can refactor it out into private methods uh, to make sure that it is conveying what is supposed to do that. And with that you get a English language like sentences which are very easier to understand and maintain. When you have these methods right now, they're private, but uh, depending on the testability, you can make them package level as well, so that you can test them further. So this is where we are. So earlier this was a method, and now we see refactored in something like this. So the question is, do we need comments? So in my view, the important thing is that make the code as clear as possible. Uh, so when do you really need some comments? It may happen that uh, there are multiple things behind the scene which happened, uh, and that kind of information you want to convey is that, for example, you do not touch this piece of code because this has been fixed of this reason, because of this reasons, because of the API got broken. So something which you want to tell uh, to the maintainer of the code base, that there it may be useful. But in cases where it is not just clear, you want to abstract it out and create separate methods for it. So that's what you can do as well. Like you first of all try to write the comments out of the abstraction you want to refactor out. So with the comments, you will be able to write in English sentence or on in your natural language what exactly is trying to do, and with that you can create your own methods. So this is a very important rule which everybody should remember. So the offshoot of the SRP is less number of public methods per class, less number of lines per method, less number of lines per class, and more classes. So the offshoot of the refactoring is having more classes. So depending on the abstractions you have, you may want to refactor them out in a new class. But why I'm saying less classes, it may happen that because of the dogmatism, you are trying to uh, uh, create the interfaces for the heck of it, for example, or you're trying to create classes for the data for the heck of it. So in those cases, I'm saying it less. So depending on situations, actually, more classes when you're trying to refactor the abstraction, and less classes when you want to have the pragmatism. So let's take another example of the OCP, object open close principle. So so what this code, first of all, if you look at this code also, it is not very much readable. By just looking at it, you are not able to read it in a natural language, and it can be refactored out. But let's before instead of refactoring it right away, let's try to see what it's trying to do. So what it is doing is it's trying to read the keyboards, I mean the characters from the keyboard, and then uh, it is writing those characters into the printer. Fine. So so right now, I'm writing to the printer, but it can happen because of certain situation that I want to write these characters to the hard disk as well. So let's try to do that. So you can create this public static, create it as a constant as well. Fine. And the same thing you can do for the disk as well, but that's not the point over here. So what we are trying to do is that if the right location is printer, then we do something, and then in the right location is disk, then we do something else. So the problem is with this case is that we are violating the principle of the open close principle. The close principle says that the code base should be open to the extensions but close for the modifications, and that is what we are violating here. We are trying to modify this code base whenever there is any else condition. So right now this we have else condition for the disk, but there can be other else condition, and then we will be changing this code base again. What if we don't have to do anything? In case we need to extend this behavior, we just write a new class, and that's the whole idea of the open close principles. Let's try to see that into the slide. So this is what happening in this class. So we want to read from the keyboard, we want to write on the console or the printer, and then we want to write into the disk as well. So this is the kind of design we can have, where we can abstract out a reader and a writer outside in terms of the interfaces. So right now the reader is a keyboard reader, but the input can come from anywhere else as well. It can come from the stream as well. And you are writing right now to the printer writer, uh, and to the disk writer. But again, this can you can extend it further as well. So whenever you need any new way of reading and writing, you just extend the class, and don't change the existing class. So so with that, you don't change existing test cases, you write the new test cases for the new class. So this is the Lisco substitution principle. Uh, so you have class bird, class parrot, and uh, class bird is the base class which can fly, and class parrot is extending the bird class, and it's trying to mimic. There is a class penguin which is extending the bird and is trying to fly. But again, as you see, the penguins cannot fly, and that's why it is trying to give the errors. So the problem with so this is a problem with the inheritance. So in case your subclasses do not subscribe to the behavior of your base class, then they may be violating the list scope substitution principle. So why? So what? So if you see the third method, play with bird. So what it's trying to do is we are passing a bird, and because of the polymorphism principle, uh, the bird should be able to fly, because that is the basic behavior of the bird. But because but in this case, you will not be able to know that because penguin is violating this principle, it will give you the error, and by definition it should not actually. So this is Liskov substitution principle. So Liskov substitution principle says that functions that use references to the base classes must be able to use objects of the derived classes without knowing it. Uh, in other words, people using derived classes should not encounter unexpected results when using your derived classes. So this is another one, so which I'm leaving for now. So class design principles are like a single responsibility principle. Each class has only one responsibility. The open close principle, a module should be open for extension but closed for the modification. And Liskov substitution principle, subclasses should be substitutable for their base classes. Let's see the interface segregation principle. So if you see over here that I mean uh, I want to use a USB cable, but for that I need to use this big uh, interface of the device. So that is the problem with this whole thing. So clients should not be forced to depend on the interfaces they do not use. So if you see this class, it is trying to contain multiple abstraction in terms of the interface. So ISP is a kind of single responsibility principle for the interfaces. So if you implement an interface or derive from a base class and you have to throw an exception in a method because you don't support it, the interface is probably too big. So why ISP matters? Single responsibility principle for the interface base classes. If your interface has members that are not used by some inheritors, those inheritors may be affected by change in interface, even though the methods they use did not change. So that may, so you may be basically depending on the base class methods in case some changes or there happens that may impact you as well. So let's move towards the testability. Testability is also a very important part of the clean code. So how to make your test non-testable? And in other words, when is the case where when you are not able to test your code base in a nice way? So global static. So whenever we talk about a global static, then we already know that that is a big problem. But when we talk about the global static, we generally forget about the singletons. Singletons also are global static, and if you basically use a single pattern, by definition, it becomes non-testable. Mixing new with the logic, if uh, so, it in case you are creating a new instance and it contains a lot of logic, uh, it may be difficult to achieve the isolation. Uh, so for that purpose, we use dependency injection, factories, or builder. Circular dependencies, which we will be talking in a little while. So mixing new with the logic, unit test. So unit test is all about testing the class in the isolation. If your code mixes the object construction with the logic, then there is a problem in the isolation. So what we need to do for that? So let's, before we see like what can we do to avoid this kind of situation, let's try to see the problem itself. So this is a one example, mixing new with the logic. So over here, what we are trying to do is we are creating in the user repository class, we are creating a database instance, and we are using a singleton class of the database. So as soon as you have this kind of instantiation, then it is very difficult to replace the database itself, because you need in order to basically write the unit test case, you may want to have a different implementation of the database. Instead of a normal database, you may want to have the in-memory database. So that instance, that implementation is difficult to change in this case, because this is I mean, this whole thing has been created. And why it is a problem? Because if you see in the login page class, then it is trying to create the user repository. So whenever it is trying to create a user repository, uh, it will it will have to basically create uh, create one, and then when you ask for the load user, then it will uh, instantiate the database. So instead of doing that, what you can do is you can inject the database from outside, and that's the whole idea of the dependency injection. Whether you use any the framework of your need, but the whole point is that this is the need of the testability, because right now you can change the database implementation based on your need. So in the login page as well, what you can do is you can replace the database with, instead of having the concrete implementation of the database, you can you can have it as an interface and pass on the the database implementation which you need. So if you are passing a db of in-memory db, then you can do that as well. And and then again you can refactor it out further, that instead of creating the, because right now here as well, like you are trying to create the user repository as a concrete instance of the user repository, you can again inject the user repository from the outside. So the whole thing of database creation, user repository creation can be abstracted out in form of the dependency injection. Circular dependencies. So circular dependencies are something like this: class A has final B, and B has final A, and this is a circular dependency in the example. So whenever there is a circular dependency, there is something which is common to both classes, and whatever is common, you can refactor that out in a separate uh, class, and that's what has been done over here. So what we are trying to do is we refactored the common abstraction in form of the class C, and now class A is having dependency on the C as well as and the B is having the dependency on A and C. So this is how it looks like in at the end. So class C is a leaf, and class A contains C and B contains A and C. So apart from these three things which I mentioned, there are other things as well. Inheritance over composition. So composition is always good because at runtime you can choose different composition. Because in terms of the composition, you will be having interfaces, and in interfaces implementation you can change at the runtime, but the inheritance base class you cannot change. Too many conditions. So in case there are too many conditions, you may want to refactor that out in form of as I said, like in form of open close principle, and have multiple implementations. Mixing concerns. So summing up, class include the word and. Class is challenging to read and quickly get for the new any newcomer. So in case there are multiple concerns in the same class, then you want to refactor that out as well in form of multiple abstractions, and that's how you basically take out the concerns outside. Static methods. So in case you have the leaf methods as a static, that is fine, but in case this is a tree method, then it becomes difficult to test. Quality of the good test case, good unit test case. So first thing is that it should do just one thing, one behavior. So it should not mix multiple things. It should be order independent. So it should not happen that you write one unit test case, and only when that get executed, other will be able to work. So that should not happen. Isolated. Uh, so so you should test your code, not the code your code depends on. It should many times we happen to see that uh, that there are names of test cases 1 2 3 4. So it doesn't reveal any kind of intention what exactly you're trying to do as part of this test. So the name should be very important in terms of the test, and this should convey what you are trying to do. They should be easy to set up. They should be run so fast and that you never hesitate to run them. So in case you, I mean, it is very important that we as soon as your code is done and you run your local build and you move the code base into the repository, But in case it's not happening, it means and because of the test cases, and it is taking too much time, then it means something is wrong over there. So tests should be very fast to run, and they should not create any problems to any person. So tests should be fast. And other thing is readable. So irrespective of whether it's a unit test case or a class itself or anything else, the thing should be readable. They should have the naming, assertions, variable length, complexity. So from all these point of view, they should be readable. You should not mix unit and integration test cases in the same package or in the same location, because it becomes difficult to basically maintain them. Good test cases need to be maintainable, uh, and from the maintainability point of view, whatever I mentioned so far is holds true, because I mean, if you have the good naming conventions, small classes, small methods, all these things are applicable over here as well. When a test fails, it should be immediately obvious where the problem lies. If you have to use a debugger to track down the problem, then your tests are not granular enough. That means you need to refactor your test further. How to write good unit test case? So use long descriptive method names. So don't worry that your test case name is long, as long as it conveys what exactly you're trying to do. Generally, uh, so in start, so once Vikas Singh says that in starting you told write minimum method, but now a single method breaking into multiple method. So I'm saying I said that you need to write small methods. I did not say that minimal methods. In case as part of the refactoring you are creating multiple methods and the number of methods is going to be large, then try to see what are the multiple abstractions in that class which are there, and with those abstraction refactor those methods into a new class. Fine. So it's not a problem where that you are having more methods is not a problem, but long method is a problem. So whenever you have a long method, try to see if you can refactor that out and create a small one, because that is easier to understand. So next one is write your test in the arrange act assert style. So that you always see that first you define what is the test condition, what then you basically act on it, and that means you call that particular method of the method in a test, and then you basically do the assertion. uh, I mean, with this whole phenomena, I generally love the way behavior-driven development tests really work. They have a similar kind of functioning. So so you have given when then over there by definition. So instead of arranging in a in a test method itself, that arrangement is done by the framework itself as part of the BDD. So you don't need to do it explicitly, but in the JUnit you need to do that. So you need to have arrange act assert style. Then always provide a failure message with your assert. So when assertion fails, then say why it failed, because then it is very easier to debug and then you can fix it. Otherwise, and also like you see like where it failed. Otherwise it becomes very difficult that something failed but you don't know why it failed. Comment the reason for the test. So in case you are having the large acceptance test cases or functional test cases, you want to make sure that you basically define the context of the test case. With that, you know what exactly this test case is trying to do. Every test must always revert the state of any resources it touch. So you have the default methods set up and uh, set up and clean up. So as part of so it again it is style uh, depending on the project. Some people, what some people do is, as part of the setup, they basically clean up, so that irrespective of somebody has done the cleanup or not, they are doing the cleanup anyway. And in some cases, people do the cleanup as part of the cleanup method. So it depends on the style you're trying to use, but the point is that as part of the test, you should revert the state of the resource you're touching. So this is the summary. So Kant's four rules for the simple design: run all the test cases, contain no duplication. So I think this is the very important four rules, which covers almost most of the stuff of the presentation, and very important as well. So run all the test cases, no duplication, expression of your design. I mean, you should be able to convey your design ideas in a system in a cleaner way. Minimize the number of entities such as classes, methods, function, and like. Then foundation of the object orientation, which is very important. And then design for the testability, where we covered dependency injection, interfaces, encapsulation, cyclic dependencies, etc. So this is it as part of this webinar. In case you have question, I'm open to the question right now.